Today we're looking at lesson 4.3 for geometry on congruent triangles. So we're going to start by talking about the definition of congruency. So they've put a few examples here of how to put that two angles are congruent or two sides are congruent, and what a congruent statement is. So if you look here, two angles being congruent, you put the angle symbol next to the capital letter and you put the congruent symbol in the middle. Same thing with sides. You want to put the two sides with the congruent symbol in the middle. And then a congruent statement would be taking the two polygons or shapes, whatever they are, and drawing either a shape of it, so a triangle, or writing the actual word polygon out, and again putting the letters to name it and the congruent symbol in the middle. So we're going to show that the polygons are congruent by identifying all the congruent corresponding parts. Now they have to be corresponding. That would be in the same position but on a different shape. And then finally we'll write a congruent statement. So it's a lot of writing. If you look at the shapes, and I've listed all of the corresponding parts here, but if you look at the shapes, they've written or labeled them with dashes or lines. So each shape has a side that has two dashes on it, so those two sides would be considered corresponding. And since they're corresponding, they would be considered congruent. And then each angle also has an indication of it being corresponding with another angle by how many lines are drawn in it. So like angle A has one line, angle W has one line, so those two angles are going to be corresponding and congruent. So I've listed all the angles. There's 4 sets of angles, and then there's also 4 sets of sides. Those would all be corresponding and congruent. And then finally the corresponding and congruent statement is just stating that the two polygons are congruent. Here we have another way of labeling, and that's just with the actual numbers instead of just the labels. So if we're going to indicate which two angles are congruent, we're looking for angles that are the same measure. So angle J is congruent to angle P. Then we can look for 2 more angles. Angle L is congruent to angle Q. And then one more set. Angle K is congruent to angle M. Since there's 3 angles, we're going to have 3 sets of angles that are congruent, and also 3 sets of sides. So then we go to sides. JK is going to be congruent to PM. LK is going to be congruent to MQ, and JL is going to be congruent to PQ. Notice I'm not looking at where their positioning is, I'm looking at just how they're labeled. And then our congruent statement, since all the corresponding parts are congruent, I'm going to draw a triangle. JKL is congruent to triangle PMQ. Now we're going to look at these sets of triangles. So there's 2 triangles that are connected here, and they are telling us that these are congruent, so we need to find the values of x and y. So we know from the last lesson that all the angles in a triangle have to add up to 180. And then in this lesson, we know that all the corresponding parts are congruent. So if we look at RSV, that triangle, they give us 2 out of the 3 angles. They have 78 and then a right angle, which is 90. So if we add those up, we get 168. And if we subtract that from 180, excuse me, I get 12. And that's going to be my 3rd angle on triangle RSV. And since that's in the same position as angle T on the other triangle, that's going to give us the value of x. So x would be 12, or 12 degrees. Then we look at the sides. Then we need to find the corresponding sides. So side RS is going to be corresponding with side VT. So we can put them equal to each other and solve that way. So 2y minus 1 equals 24. So 2y equals 25. So y would be 12 and a half. And that gives us x and y. The next example, we're going to look at another theorem, and this is called the third angles theorem. It says if two angles of one triangle are congruent to two angles of a second triangle, then we can also conclude that the third angles of the triangles are congruent. And that's called the third angles theorem. So keeping that in mind, and other things that we've done in the past and also in this lesson, we're going to look at this diagram. It says that angle WNX is congruent to WRX. So WNX is here, WRX is here. So we're going to indicate those two are congruent. It says WX bisects angle NXR. So NXR is in the middle here because this is at X. And if WX is bisecting it, that makes this angle equal to this angle because it's splitting it in half. And then it says angle WNX is 88, which is here. So with all those labels, oh, and then it also says NXW, which is down here, is 49. So we need to find NWR, which is up here, this one here. So NWR, we know that 2 out of the 3 angles for this triangle NWX, so there are 88 plus 49. That gives us 129. If we subtract that from 180, that gives us half of NWR. So that's 51. So right here is 51. And since WX is bisecting NXR, it's also bisecting NWR. So that makes the other side 51. So our explanation here all right, I look back and I realized that my calculations were way off, so let me do the math again. Sorry about that. Gives me 137. So if we subtract that 137 from 180, we're going to get 43. But the same rules all apply than what I just said. So 43 instead of 51. So that's 43 and 43. So if we add those two together to get the entire angle, which is what it's asking, that gives us 86. And our explanation can really be our work. And the last problem is going to be a proof. So just in any of these lessons where we were proving things, they've listed properties of congruence. So we have the reflexive, symmetric, and transitive property. This is just applying to triangles specifically. So we've also had this with sides, we've had it with angles, pretty much all parts of polygons. This is just saying for triangles. So if you have one triangle, ABC, that's obviously going to be congruent to the same triangle. Symmetric property is just flipping each triangle on the side of the congruent symbol. And then transitive is basically, like I've said before, is taking out the middle. So if you have one triangle equal to another triangle, and then that triangle equal to a third triangle, you can assume that the first and the third triangles are also congruent. I don't believe we're going to use that in this proof, but we need to think of some parts that we already know, and we need to prove these two triangles are congruent. And we're going to write a two-column proof. So 2 columns, it's been a while, but we have statements, and reasons. So we always start with our given, and that's all here. For lack of room, I'm just going to assume that that's going to be right across from it. So our given is given to us. Our given is angle J is congruent to angle P, which they've labeled on the triangles. JK is congruent to PM, which they've labeled on the triangles. And JL is congruent to PL. They haven't labeled this, but they also said L bisects KM, which makes KM cut in half, which actually also makes KL congruent to LM. So with that information, we can first start by coming up with the fact that angles are congruent. So we have angle JLK is congruent to MLP because they're vertical. Those are right here. So let's list that first. Angle JLK is congruent to angle PLM because they're vertical angles. And this is in previous lessons that we've learned that vertical angles are congruent. Then, like I actually said from the given, LK is going to be congruent to LM, which I labeled, and that's because of the definition of a segment bisector. It splits it into 2 equal parts. So we'll list that. And then our third statement, we have angle K and angle M. That is going to be the third angle because we have 2 of the 3 angles. So the third angle, remember with the third angles theorem, is going to be congruent because 2 of the 3 angles are already congruent. So angle K is congruent to angle M because of the third angles theorem. So now we pretty much have all of the angles and sides corresponding with each other, and all corresponding parts are congruent. So we actually labeled this, and if you remember, this was a while ago, we talked about this, CPCTC, which means corresponding parts of congruent triangles are congruent. So triangle JLK is congruent to triangle PLM in that way. And this should help you with one of your problems on your homework. You can use actually many of these same statements and reasons to prove the 2 triangles are congruent. And that concludes lesson 4.3.